scimax channel. I'm going to continue with the fourth video in my series on electronic lab notebooks and trying to get FAIR data as part of them in computational work and possibly with experimental work. And so I've been working on how to cache data, how to save data in a usable, findable, accessible, interoperable way. And last time we looked at using SqlCache, we looked at joblib before that, and today I want to look at a new variant of SqlCache. Now, this notebook is a project in org mode sense. It's a directory and every file in it is connected. And I have a command called nvagenda, and I can use that to find tasks. So here I left myself a task from the last time, and we're just going to visit it. And the idea was to integrate orjson for serialization into SqlCache with storage in SQLite. And the goal of that was to make it more easy to search. So with joblib, it normally makes something like a pickle file that is not interoperable. It only works in pickle. And it's also not easy to find anything because you have to do a brute force linear search. And I'm going to show you, hopefully today, that we have a new version of SqlCache that solves some of these problems. So naming files is hard. I keep this, this is part of a journal. Here I can just create a new journal page with a few keystrokes. So you see down here we're at 0618, that's today. And I'm going to call this using SqlCache. This is a new version, backwards incompatible version of SqlCache that is, you should be able to find it on the PyCSE GitHub page. And after I run it a few more times, I'll push it out to pip. Probably we should have a little graphic here. It's easy for me to do these kinds of things. This works with Emacs and a Mac. I have a little key binding that lets me put a screenshot in. And so again, this is going to be the fourth video using SqlCache, or this cute pig saying SqlCache, that I want to introduce to you today. All right, so let's jump into how I think we're going to use it. We'll say from pycsc.hashcache import SqlCache. Now the biggest difference in this new version versus the previous one is the previous version was a function-based decorator, and this is a class-based decorator. And otherwise it acts the same. We're going to just use all the standard defaults, and I will decorate this function f of x and have it just return x for now. And now let's just call it a few times with a couple of different arguments. And how about f of a string? And so this should run and outputs the functions. And now let me show you what's in here. We have this cache.sqlite, and that is where all of our data is. So I can show you that, I hope, by here, SQLite 3, I think. Let's do cache.sqlite, and let's select star from cache. So there's a table in here, and we can extract all of the rows in the table. And so what you can see from this, it's a little bit tricky to see, but there is some data that is stored in. There's a key, that's the way we identify it, and then there is the value that's over here. And I store a bunch of things in here. I don't understand this host name. That is something Python pulls. I store the current working directory, the version, the standardized arguments here, and then the output. And so this is automatically being stored in SQLite, and it's being stored in JSON. And you can see we have here a function. Let's go down here and decorate a new one. SqlCache def g of x, and let's return 2 times x, and I'll do g of 1 and g of, let's do a list 2 comma 3, and that also works. And now if I run those 2 lines again, it should read it from the cache, and you'll have to trust me here that it does. I didn't make it play a sound to make it super obvious. But that allows us to do some searches based on SQLite. So let me switch to a Python block here and import SQLite 3. And then let's do let's see what we need to do here. I need to figure out how to load this in a SQLite database, and then I can show you how it becomes a little bit more searchable. Okay, so we need to make a connection here. So I'm going to say the connection is SQLite3.connect, and let's find that SQLite file. So we can connect to it to make a connection. And then we need to run a SQL query. So that's going to look something like con.execute select star from cache, where, and this is where the magic comes in terms of interoperable. We can do this JSON extract, and we're going to extract from the value, and we're going to look at $, let's say, let's look back up here. Let's look for func is equal to g. So func, and I need to make this a regular quote, equals g. Like this. Let's say, I think we normally call this a cursor. And then let's do print cur.fetch all. And let's look at the results output. And this will find all the entries where there's a function named g, and we can then extract information from this. Now, it's a little bit subtle. You might notice that this is a byte string, and so we do have to be able to read that byte string into JSON. There is json.loads, and there are other libraries that can read JSON, but this makes any library that can read SQLite now can search through all of the entries that are in there and find them based on different criteria: what function you ran, what the keyword arguments were, etc. You could find out what path it was run on, and other kinds of things like that. So I'm playing a little bit fast and loose with interoperable with Python and Jupyter Python. They're both Pythons, but we use SQLite here, and I think you could probably do something like this in a shell and pipe it to JQ. seems moderately reasonable, but I haven't done it and don't normally need to do it because I'm just fluent in doing this with Python. Okay, so let me show you a couple more interesting things that you can do with SqlCache. So that is the traditional way I've shown you, where you decorate a function to store the function in the cache. You may want to just store some variables and have that also be a fairly straightforward thing to do. So let me define an ODE real quick. And let's say this is dy dx equals y. And then from solve from scipy dot integrate import solve IVP, and then let's say solution is equal to solve IVP ODE. Let's integrate from 0 to 1, and initial condition is 0, and then we'll have our solution so we can see what it is. And so we see this solution, it ran. Oh, maybe I should make this more interesting and make it 1, and we should probably make this a minus so that it decays. That makes more sense to me. So now it's going to just decay down. We have a solution, and I might like to solve or save this for later. And so I can say sqlcache.dump, and let's say solution equals solution. Now currently this is a potential breaking feature in the future. I currently require keyword arguments here, and that's because we're going to be able to retrieve it by this name, and I'm not positive that's the right thing to do, but it seems to make the most sense to me. Now we see we get this hash, and we can use this later. SqlCache .dump .load, and we give it that that hash, and then this will reload something that is very similar to, but not exactly the same as, the original solution. Let's see if I can make this be maybe something in code or something so it's more obvious what we're looking at. I think maybe I can print it. I think that worked before. Here you can see we get a dictionary, and the dictionary has the solution, and it has a name here, but what this is not is the same thing as the object we had before. It has all the information in it, but it's in a different form. And this is something you should always be thinking about when you're serializing, of what's the round trip return. So I can still use this, and let's say I wanted to make a plot. Let me load the matplotlib, and let's say solution underscore is equal to this. Then I would say plot.plot solution underscore, I think t, comma solution underscore comma bracket y, and I think if I did this right, we should get a figure that shows no. All right, let's inspect what we get here. All right, so I need to say SOL here, and now we should be able to make this plot. Maybe I need to put a bracket 0 here, and now you see that plot. Okay, so it's a little bit reusable. Maybe some other subtle points here is of things that are lossy. The solutions used to be arrays, and they're probably now lists because we serialized to JSON. Maybe that matters, maybe not. That is something you have to test, learn, understand, and make sure that what you're doing isn't affected by transitioning from a list to a NumPy array and back and forth. There's a couple of things that can happen in there. One is if you have a pipeline that is multiplying the data, then you have to convert this list into an array before you get element-wise multiplication. If you have something that switches between 32-bit and 64-bit floats, you can lose precision in this round trip, and every once in a while you'll find that happens. So I think it's fair to say there's no single bulletproof answer for doing this, but we have in this example here, I think SqlCache is pretty close. It solves the problem of interoperability by storing the data in JSON. It makes the findability better because we can leverage SQL for the search. It consolidates all the data into one file that's easy to share and easy to move. And otherwise, you just have to, learn a little bit about the underlying data structures and what changes and how to search it if you're going to end up doing that. I also enabled this ability to dump and load variables without you having to come up with a name. And it tells you the name, so that may or may not be useful, and I'm not positive that we're going to keep with this this structure here. The benefit of this is you can look up things by name. Of course, the disadvantage is you have to know and remember the name. And if you were doing this at a large scale and you didn't document it, then you might find yourself in a bad way. But this does let you do some interesting things, and I think it's getting one step closer to being able to solve some of our problems. So let's see what we got started on. I'm going to go back to that particular example, and so we'll go A, J, and then I can scroll through my journal entries. P, this was the first one. I think this is pretty close to what we were trying to do. We were trying to solve this for a variety of different solutions for K. So let me see if I can just copy this so I can go back to where we were. Let's see, today is the 18th. Okay, so let's see if we can put this all together. So here I need to make this at SqlCache. And this is going to give me a function for the solution of K. It's going to integrate new something here. It's going to return the solution. And so I can do, what's this called? Solution. Sure, I don't want K is 0. And now I'm going to say let's just run this. Well, that should be K. There's 1, 2, 3. We ran it 3 times. And I should be able to run this again. It should be lightning fast. There it is. Let's have a look at solution 0. We have that. So now for SOL in SOL, let's do plot.plot solution. Since I ran it a second time, I actually have to do it this way, I think. And I think I can just transpose this. Yeah, I probably have to put a little K here. And let's these. What did I do wrong? List op. Oh, this is a great example of where I converted it to a list and have to convert that back to an array. So I predict many people are going to run into issues like this, and that is a general feature almost certainly of using JSON and getting a list where I used to have an array. So it's more reusable. It's not unusable, but I don't know a good way to get both things at once. If you want this to be only usable in Python, Pickle is certainly a reasonable way to go. But this JSON file in SQLite is going to be usable for a long time. So I don't know what the right answer is. It might depend on the scale of data you're looking at. If you could also make this work with something like a Mongo database, which is a totally NoSQL document form, and then you could store things. You'll probably still have the JSON serialization issue, and it'll have to get a lot more sophisticated if you want it to somehow convert back to an array. You'll have to store information in the database so that when you read it, you can tell Python to convert it back. So let's see what we have here. I have K and SOL. So let me just say let's dump that to a variable. So that was SqlCache .dump, and I'm going to say K equals K, SOL equals SOL, and that should have printed a hash that I'm going to keep here. And I'm going to make another task here. See if we can read the hash above from another location. Okay, let's see if I can just do it. Let's make a journal entry for tomorrow and see. So I can do that by picking tomorrow with the selector, live stream mode, JP, from pycsc.hashcache, import SqlCache. One of the things I feel like I lost with the class decorator is I have to manually set the cache attribute here. And this is going to be in 18. So I think I can probably use a relative path. Okay, that has to be a string. And then SqlCache.load. Need to put a hash here. A little inconvenient to copy this. It's not really like machine readable and whatnot, but I think you won't always need that. So let's see if this runs. And it does. So now, from another notebook, from another file, I just give it a path to this cache.sqlite, and we can get the data and reuse it in another place.